Let's talk about diodes, right? So what does a diode do? Told you before, it only allows current to flow through in one direction. Okay, that's the next page. So you got something called LED, light emitting diode. So it emits light when current goes through. So how to know, okay, circuit A and B, which one will light up? A and B, which one? A. How you know? Because you see over here, you look over here, the arrow is pointing this way. That means the current goes through here this way like that. It allows the current go through. So this one will light up, no problem. Okay. Okay. And then after that, if it's the other way around, like that, current cannot go through. Why? Because this is pointing opposite direction. It has a very high resistance when current is going to try to go through this way. So does it mean the lamp only lights up? Well, this doesn't give out light. Is that true? No. Okay. So don't get it wrong and say, only lamp light up, but this one don't give out light. Okay. Both also don't light up because it is not a closed circuit in the end. Okay. So this only A works. Okay, then after that, look at this over here. Later on, you will learn what's a CRO. What's a CRO? It displays waveform. So it's a device which shows you the waveform. If for AC mains, what kind of wave will you see? I told you before, you will see a sine wave like that, right? Why do you see a sine wave like this? Because its potential for AC alternating current is constantly changing. AC, alternating current. So it alternates voltage. So it has a positive voltage, negative voltage. Then next moment it becomes negative, positive, and so on. Okay? So if you have a diode here, and okay, let's say I put one lamp here, Okay, I don't need a lamp. I don't want a lamp. I just put a diode here. What's the effect with an AC? What will happen? What will you notice? What will you observe? What will you observe? You on off, right? You will blink, right? Okay, so you give out light. Okay, if this is a LED, you give out light one moment, and then after you don't give out light the other moment. Okay, and so on and so on. Okay, so if you put a CRO across the AC over here, if this is a CRO over here, you will see a waveform like that, a sine wave. Alright? With a positive and negative, because it keeps changing. Now, you put a CRO over here, what kind of waveform will you see? You allow current to go through one way. Then after that, what happens? It doesn't allow current flow, right? So, what happened? Flat line, correct. And then after that, allow current flow, and then after that, don't allow, and so on and so on, like that. Okay, so this is the end result. Okay, can you draw something like that? Can this happen? Yeah, of course. It can also be like this. Okay, it doesn't have to be all positive on top, right?
What was the purpose of the alternating current?
Alternating current. Later you will know a few chapters down why we have alternating current. The idea for alternating current is for actually the efficiency.
And that's the DC also.
Yeah, there's a DC, there's a direct current and AC law. So this alternating current, then all these normal batteries you see here are what we call a direct current. Okay, so that's the purpose of this. Okay, wow, okay, here comes today's main stuff. So stay awake, stay alert. For next two chapters you see you look at all this, you'll be wondering, wow, what is all this, man? Okay. Okay. So this is what I'm going to talk about is called a potentiometer. What is a potentiometer? You don't think, potentiometer is something like ammeter, is it something like voltmeter, right? So to measure something, right? No, it's not. It's not an instrument to measure something. A potentiometer is a circuit setup which can look something like this. In fact, it looks something like that. Alright? Okay, so you will definitely do this in the lab. You will handle potentiometer, but you don't even know. Okay, it's a potentiometer. Okay, So what's the idea behind this potentiometer, or what we call a variable potential divider is this? You want to be able to regulate potential difference across a device. Okay? So we want to be able to regulate potential difference across a device. Okay, so you see you have already handled something like that. So if I give you a circuit like this, you say, oh, series circuit, very easy. Yes, it is very easy. You should be able to handle it. Okay, so the fundamentals is this. Okay, R1, R2. Let's say I say this is 10 ohm, this is 10 ohm, and I tell you this is 10 volts. Without calculation, I think all of you can quickly tell me, I really hope, V1 and V2, the values are what?
10, 5, 5,
5, right? 5 plus 5 give you 10. Right? So you make a very smart guess. You say, hey, since these two are equal, right? That means this one is 5 volt, this is 5 volt, this will give you, and they must give me 10. You are right. Okay? So if let's say I decrease this one. I decrease this one to 2 ohms, and this one was 8 ohms. You make a good guess. You will probably say that this is what? Without calculation, the voltage here will now, this voltage will be what? 8. Then this one will be 2. Right? Correct? You want to convince yourself by calculation, can. You want me to talk about RRIV, the thing to convince you, also can. Now the main idea is this, you already should know how to explain it this way. I want you to realize this as well. Look, when this one's resistance falls, resistance of this fall, this one will also fall. So R here drop, V1 will drop. Okay, if I increase R2 voltage, R2's resistance, this voltage will what? Increase. You must know 1, how to explain in detail. 2, you must also know the shortcut, the very fast way, the end result. That you increase this, this voltage will fall. You decrease this voltage will fall. Okay? So you can just imagine, if I keep increasing this one, increasing higher and higher, this voltage over here will keep falling and falling and falling. Okay? So then if you, whatever you put here, you put a light bulb here. And if this voltage is keep falling, this lamp will get what and what? Dimmer and dimmer. So where do you use such a potential divider? Well, you use it in a brightness control, volume control switch in a room. Okay, so you turn the dial, okay, you can control the brightness and lamp, the brightness of all the light here. Switch it until very dim. That means what am I actually doing? I'm decreasing the resistance here. And as a result of decreasing the resistance, the voltage will decrease. Then you get dimmer and dimmer. Then it's Valentine.
Oh God. Then we gave you a Valentine's.
Oh no, that was recorded.
Huh? Oh shit, it's died. It's died.
You go viral in Maristella. Okay? So you see over here, if I want to vary by voltage here, I keep on changing my resistors. In, out, in, out, in, out. But that's very troublesome. So we need a more efficient setup than that. Okay? But before I show you the more efficient setup, we do the fundamental first. Everybody please pay attention. You don't, 2 pages down, you have no idea what I'm talking about already. Okay, so really pay attention, stay awake, stay alert. Alright? Okay, look, so I'm going to convince you by showing the working. I'm not just going to tell you, you just get convinced. You will see, you can do this. Okay, so what is the relationship between V out resistance and VE? Okay, VE is the EMF. So the current through R1 and R2 is given by what? So you should be able to calculate this. If you cannot, then we are in big trouble. So I equals to this one, I will call it VE. Okay, VE. Or let me just call it V total. Okay, I think you all prefer it to be called V total than VE. So let's call it V total. So V total, I want a current, so R is how much? R1 plus R2. Okay, so everybody should know that, right? You say, okay, I know that, it's easy, okay. So all these are very easy. The fundamentals building up is very easy to convince you, right? Then after that, V out. I want to find V out. What is V out over here? So V out, this V out is equal to I times R. The current I already found that this horrible expression over here is like that, right? Times R. Why is R? R1 or R2? Demarcus, R1 or R2? V out is across here. So this R is R2. This is R2, right? Okay? All following so far? Follow, huh? Look, huh? What else do? I rearrange the thing. So it looks like this, right? So you know, this V total, take notice, this total, this V out. So you notice this expression, okay? If let's say this is by resistor number 2, right? Let's change it to V2. So V2 is equals to, what's the expression? It's actually a proportional expression. That means it's showing that V2 is a proportion of V total. And how you get the V2? Remember, on top here, actually it must be R1 or R2. R2. Okay, this will be R2, this will be R1 plus R2. Okay? So, this is another way of finding V2, right? Other than you can always use your I equal V over R, no problem. Then you can also use this relationship. So if I want V1, what's the proportional formula? Let's call it the proportional formula. Then on top here, R1, correct. Okay, so R1 plus R2 times V total. You will get V1. Okay? So that is a proportional formula, so to speak.
Stuff in the bracket you multiply by V total.
Yes, because it's a proportion of the total voltage from the battery. Okay, but said and everybody, I say again and again and again, it's very useful to know this. If R2 is decreasing, my V2 will decrease. Okay, very useful to know. All right. If my V1 is increasing, rather, if my R1 is increasing, my V1 will be increasing. Okay? Because it's proportional. Okay? So this applies only when there's two resistors here like that. Okay? Okay. So, next part. As B is, as R1 is increased from the minimum, then here I'm convincing you by my RIV again. Right? So over here, what did I do? I replaced this with a variable resistor. So when I replace this with a variable resistor, I slowly increase this from a very low resistance to a higher resistance. This is my first R, my total R, total resistance increases. So the total current in the circuit will decrease. Yes? Okay? And then V out. What will happen to V out? So the current coming here now, this current has gone down. So if this current has gone down, my V out will also go down. Yes. Will decrease as well. Okay? So that's RIV. Right? Whereas the for R1, okay, this R1 is so small, cannot see. It will increase. Why? Because V total equals to V R1 plus V R2. This is the same. This is going down. This one must increase. So I give this as my reason. If I don't say my reason is this, why can't I use this as my reason? Because inconclusive. This one, the current is dropping, whereas this one, the resistance is increasing. So this is inconclusive. Correct, no, Yihui? Understand that, huh? So why I choose to give this as my reason, not this. Okay? So I show you by calculation how you get this proportion formula. And I also convince you and tell you, always remember, if this resistance falls, this voltage falls. Okay? And you also know by RIV. Okay, so here we have two resistors, one variable resistor, one resistor. Very troublesome. So to improve everything, what they have is this setup. Okay?